Hello, today I'd like to talk about statistical power. Now previously we've talked about the p-value. With the p-value we're considering this type 1 error. Of course if the p-value is low, the null hypothesis must go. But there's a flip side to that. Remember, if we're doing a test where the null hypothesis, let's say, is that the mean is equal to a certain value, the alternative hypothesis is that the mean does not equal a particular value, what happens if you get a p-value, let's say, greater than 0.05? Well, you're going to fail to reject the null hypothesis. There's a problem with that if you are making the mistake of incorrectly keeping the null hypothesis. That's a type 2 error. A type 2 error, we incorrectly keep the null hypothesis, and that error rate, we call that beta. Of course, type 1 error rate we call alpha. Now, when we do let's say a designed experiment, we will purposefully try and keep the power, the statistical power, to be 80% or higher. So what is power? Well, if you think of the value 1 minus this type 2 error rate, beta. Of course, beta is a probability. It's going to be between 0 and 1. So if you have a beta value of 20%, let's say, then the statistical power, 1 minus beta, is going to be 80%. Statistical power, that is where you are correctly rejecting the null hypothesis. So power is a good thing. You want your test to have a good statistical power. One thing that you'll find in practice is that people will fail to reject the null hypothesis. Let's say they get a p-value greater than 5%. So they'll say, oh, okay, well, it's statistically insignificant, therefore there is no difference. You can't say that to begin with. You can't accept a null hypothesis. That goes against the scientific method. Another thing that I will criticize you on is, did you take a large enough sample size in the first place to be able to correctly detect a difference of a practical difference that you would want to be able to detect? If you think of these elements that you have to consider when working out sample sizes for performing a design experiment, you need to think about things like the type 1 error rate, the type 2 error rate, this difference that you want to detect, how large an amount of variation you expect to see in this experiment, and the sample size that you would want to take. If you take all of these into consideration before you do the design experiment, which is of course what we should be doing, this shouldn't be an afterthought after you've collected the results, then okay, if you get a p-value greater than 0.05, then sure, there is a statistically insignificant difference. But all of these considerations have to be borne in mind before you start going out there and collecting the data. Power and sample size determination. This is not a moot point. This needs to be done before the designed experiment is initiated.